what we're speaking about here is how do you scale for data centers where there's an uncertainty and flexibility of the demand that you've got, and also at the same time you need some sort of certainty about your financial obligations and your commitments as data center providers. And man, I'm going to start with you on this, because you said part of this challenge, how you plan for capacity and flexibility, it is challenging because people have gone from having 10-year plans that they're working towards to suddenly their time horizons are much shorter. So what's your thinking about how you reconcile some of those forces?
Yeah, so as you say, it's difficult for us when we're looking at the physical infrastructure for a data center. So for us, it's a 3 to 4 year commitment typically from go to woe in terms of getting a data center up and running. So it takes us probably about a year or so to find a piece of land, to go through the purchase agreements, to get everything arranged for it, to get the power arranged. Then we go through a design period, then we go through construction. So for us, it's a 4 year period, and construction is typically 2 to 3 years on the back end of that as well. So if we're looking at something which is at the moment changing in an incredibly rapid rate, we're getting new racks coming through probably on a 12-monthly cycle at the moment. For us trying to sit there and look ahead and go, what are we going to be putting in? What are we going to be building in 4 years' time? It's really hard right now. So the best we can do is sit things and go, how do we keep this as flexible as possible? How do we build a data center which isn't going to have too much space or isn't going to have enough power, isn't going to be able to cool things? I mean, we're seeing a massive shift in how we're cooling things at the moment. As an industry, we've been heading for the last probably 10 years down a really sort of high-density air-cooled solution. We're maxing out on that now. We're having to go to water-cooled solutions everywhere. We're putting in water-cooled racks, all of the new NVIDIA pods that are coming out, and a lot of the things that are happening with all of that sort of high-density compute. We're basically having to try and hedge our bets as best we can. So rather than having a very optimized solution in a data center, we're now building things which are much more flexible, much more open, and much more able to change, to adapt to what's coming down the line.
But Adam, you're getting to a situation, I mean, you're in the circumstance, in public knowledge, data center knocked back in Lane Cove. I mean, it must be hard for an organization to plan when you've got this sort of challenge of the mindset that you're dealing with. You know, people don't recognize the task and difficulties you've got about things.
I think a bit like what Matt said, ultimately is one of the big challenges. I think Lane Cove is perhaps an example, is a lot of the demand that data centers have are us. Like, data centers can't just simply be there and draw power by themselves. It's all of the digital economy that we're all using every day. So some of the challenges that we have, as Matt said, are ultimately trying to build for what tomorrow looks like. Because if we still look for the last 10, 15 years, we've been in data centers, it's been 3 to 5 to 15 to 30 kilowatt racks, and now we're talking 1,000 kilowatts. That's a fairly substantial jump. But we're at the moment now, how do we build for 1,000 kilowatts? That's not every customer is clearly not running 1,000 kilowatt racks, but clearly these data centers are built for 20, 30 years. So much like you said, we're looking at how do we build the back-end infrastructure to a large extent is to some extent similar. And then how do we build it in a modular fashion so that we can adapt very quickly. If in 12 months' time we say this many customers are now using NVIDIA SuperPods, we can adjust to that. So yeah, it certainly is a challenge. That's why I look like this. It's a challenging environment.
But Peter, everyone wants your demand. I mean, you're one of the big, if you've got you as an anchor tenant in anybody's data center, they're going to be over the moon for it. But you can't really forecast the demand that you're going to need in the future.
I guess we kind of can. We know, what we can tell you is our demand is always more. And that is the challenge that we've got. We've kind of stopped thinking about our technology futures beyond 3 years, and what we do and how we do it, because what we're experiencing, is what we thought we knew yesterday is not the same as we know today, and we know it's not going to be the same as tomorrow. We know we need compute. We know we need to run warfighting networks and protected networks and unclassified networks, and we need compute to do lots of things to enable the defence of the nation. But it is really hard to predict what that looks like in terms of capacity and compute. We are driving hard to move to cloud. We have built data centres in the past and we want to get out of that game. We are not good at it. These guys are good at it. Cloud providers are good at it. We just want to get out of it, but we still need to do it on some bases. And it is a really challenging space for us at the moment. And what we do see though is the evolution of compute, the high density, AI capability is really hurting us in terms of power. We've got compute on bases where we would use 5 times the base's capacity to provide compute if we built a data centre on it. And so we are kind of grappling with how we're going to deal with some of those issues. And a lot of it is to go to commercial providers and use off-base compute and get that secure as we need it to get it on. But it is a really challenging time at the moment.
Okay, and I want to come to the issue of sovereignty later on, because I think you've got some interesting perspectives on that. But I'm interested in this issue of flexibility, and I think, Adam, you were talking to me about almost a Lego-like approach. What you do in software development, you can do within the approach of how you design, but that actually means that it's the capacities within the land around you to extend as needed.
Yeah, I think we're quite fortunate in our scenario that you can't overshoot the demand. So there's just so much demand coming from a data center perspective, that is, and to some extent, like the compute, nobody's ever said I'll have less compute in the history of the last 50 years or thereabouts. So we're very fortunate that we know there's a significant amount of demand, and the more we can turn our designs into a modular approach, we can go and buy 100 generators. We can go and buy the long lead time things are quite challenging, but we could go and buy 100 generators, and we know that we will see the demand, whether it was in this region or another region perhaps, as in, could be in Sydney or Melbourne or otherwise. But yeah, certainly we are trying to ensure that all of those Lego pieces per se are in a modular fashion as best you can. Like some things it takes a certain amount of time to get a generator, 12 to 18 months depending on where it is, same as power. The power takes time to get there, but the more modular we can make that, it means that we can slot in certain elements to try and scale and adapt as customers need.
In talking to you in preparing for this, what impressed on me is part of your challenge is the type of demand you get. You could get demand for very GPU intense, AI-driven type clients who need high capacity and smaller normal loads that you might get today. And it's difficult to know who's who in that environment for you.
Yeah, very much so. And I think if you talk to pretty much everyone here, could you forecast out 10 years? No chance. Could you forecast out 3 years? Maybe no chance. Could you forecast out a year? Okay, I can probably get to that sort of time frame. And I was just talking to the guys earlier about, I was speaking to someone not in NEXTDC, but a really switched on person, and they said, yeah, we haven't used AI because we used it a year ago and it just didn't really work for us. I'm like, well, that's like 100 years in AI terms. And so it's moving just so fast. And so where it gets to, I've honestly completely lost your question of what I was going to ramble off for hours, but
no. Let me bring in Peter, because Peter, you were talking about going on a study tour to the US, and you've seen probably the latest and greatest data centers there, and I think it might be interesting to share what you saw and how they're building them over there.
Yeah, probably the two most marked things we saw was, one was the hyperscalers particularly were buying data center property, and they were buying, land 5 times, 10 times the size that they would need for the data center. And next to the data center, they were building wind farms and solar farms. Up near Seattle, they were running them off nuclear or water turbines. And we were just kind of really struck by the fact that when you talk to people in Australia, in Sydney, running data centers, they'll say to you, yeah, we've got to do this renewable trade-off, and we're looking to kind of stick some solar, out in Western New South Wales somewhere, but they still want the data centre in Sydney, the power that they can get from multiple power sources running into North Ryde and other places. And it was kind of really struck us that like the US guys are not sticking them in main cities. They are buying rural land in the middle of nowhere and generating their own power and getting the compute connections to good speed to work. The other we saw was the water-cooled capability on their compute, like running CPUs and GPUs in water. And in one instance, they were basically water positive and power positive for the city they lived in. They were returning power to the grid through the heating of water. It was pretty cool.
Yeah. You also were impressing on me that we've got to start thinking of our data centers in terms of campuses. And you've got to think these are things that we probably should be looking outside Sydney, 150 kilometres from Sydney and Melbourne, building these sorts of environments. Yeah,
absolutely. Yeah, there's a great opportunity. Look at Australia. We've got plenty of land. We've got plenty of asset in terms of resource. There's a lot we can do.
Matt, you were talking to me. I got into a physics discussion with you on sort of the issues of water cooling, and then you've got to go into other forms to manage the temperatures that these things are going to generate, and how do you get rid of the hot water that's created. Could you share some of that thinking with the capacity challenges, and then thinking about that in terms of the workloads that you're trying to satisfy?
Yeah, so I mean, one of the big things we're seeing around coming out of a lot of policy discussions at the moment, and particularly with authorities, is around restrictions on the services that are coming into sites. So we're talking a lot about power, and everyone's very focused on getting power to site. You say about sort of heading out 150 kilometers away to get sort of options to put solar in and put infrastructure in. The other corollary to that is then what do we do in terms of water? Water's the other big resource that everybody is struggling with. And if you look at a lot of sort of the high density locations, I mean, Macquarie Park's a perfect example. It's really hard to get water at the moment. So everything we have at the moment is a trade-off. So we either spend more power and we burn power to cool their equipment down, or we use water for it. And if we can't get water, then we're forced to use power. So there's a loss of efficiency in either way. So we either take away an asset which is basically provided for people's sustainability and livability, which is the water, or we basically generate and you use more power, which has the downside of, in a lot of cases, we're polluting, we're providing sort of extra carbon into the atmosphere. So we've got a lot of things to balance around between those different options. And as we sort of, I mean, if you look up in sort of Southeast Asia, what we're seeing is a lot of the water options are just not available. So they're taking that offline and basically forcing us to use more powered solutions, using air-cooled solutions for data centers. So for those sort of transfers, it's making a big difference to us in our business cases, what we're putting together, and how much capacity we can actually provide out of any facility.
Your boss, Adam, has got some quite contentious views on how we power the AI revolution, quite strongly feeling, and we've gone through an election, so it's been put off the table at the election, but he strongly feels that the only certainty about power is going to come from something like nuclear on that. And you were telling me you had concerns about renewables and its storage capabilities to do that. Can you share that thinking?
Yeah, very much. So Craig Scroggie is very much on the nuclear bandwagon, and for ultimately, he has good insight into what the future requirements of power are, which are very, very, very vast. And I think many of us wouldn't necessarily see that. To put it on the record, I'm full support for renewables, so not going to get paint bombed outside. No, I think that renewables are certainly really, really valuable. Obviously, we've got a massive country, ton of space to put them in. Solar as an example, we've got an excellent environment for that. But the challenge is data centers, like Bevan touched on this morning, are steady state. So very, very often they're very steady state, and so clearly we need to look at how do we enable the storage of that energy for the times the sun isn't out, as an example. And I think there's not really quite a good understanding yet of just how much power is required. So we can run batteries, but we need many, many, many multiples of what the biggest battery in Australia is at the moment if we're thinking about what the future is like in 5 years' time. So again, I'm stealing much of Bevan's thunder from this morning, but a lot of it is thinking about logically putting aside the emotive part of nuclear. Is that a really good power source that we'll need? Because ultimately, if we don't have the power, we will fall behind in many of the competitive digital environments that we're trying to work on.
But I want to take a point that you said in our preparation, Adam, and that was data center people have been pretty poor in selling to the public how much they need big data centers to drive what they take as for granted digital world that they live in. And I just wanted you to share that thinking. Yeah,
for sure. I think we have done a pretty poor job just as an industry of explaining we are really a utility. It's a bit like power. People don't really think about how the power gets here, I guess. So they just, I've got my power, I turn my kettle on, it works. That's very similar to if you're looking at using Teams, talking to people, virtually anything we do, whether it's buying things at the shops. So often data centers are just hidden behind the scenes and people don't necessarily know what they are. One of my favourite jokes, driving past the data centres in Perth for the 8,000th time, is say to my kids, how many people work in there? And obviously my kids know the answer, but any of the taxi drivers are like, probably 1,000, there's like 5 people in there. Yeah. And I think that we'll come to that in a moment. But yeah, we really do need to better educate not just this audience, but probably they'd be well familiar with that, the broader audience, that data centers are a symptom of your use of technology.
Yeah.
Obviously, if the consumers aren't using it, then we don't draw power if it's just sitting there.
And what I picked up from you, Peter, and Adam, Matt, I'd be interested in your thoughts on this, is even a client as large as defense is recognizing, I don't want to build data centers. I can do better things with the resources that I've got. So the world is looking at providers like yourself to provide the foundation for a digital economy. How easily do you handle that responsibility, I suppose?
No different to what we've been doing for the last 10, 15 years. I mean, if you look at the shift of our computing life cycle as we've progressed over the last couple of decades, we've gone from that sort of building a computer room in every office to moving those computer rooms out into a centralized facility somewhere and building that as an enterprise facility, to moving that into a co-location space and having it off-site, to moving that to virtualized space, moving that to cloud. We've gone through all of these cycles, and I think as an industry, we've always managed just to keep ourselves very low-key, very much under the radar. NEXTDC I love, because they're probably one of the few that really don't do that. They wear their colours proudly, and when you drive into Perth, you can't miss the NEXTDC, the P2 is right in front of you. And when I go across Burnt Bay Bridge, heading across into the city, you see S3 across on the side. So NEXTDC wear their colours proudly, but they're very rare. Not many people do that. Most people still keep themselves very low key and under the radar. And if you look at it, like I said, we're a utility. But if you talk to most people, you ask them, okay, what do you know about a data center? And they go, well, I don't know anything. And so you say, what about the cloud? And they go, oh yeah, it's where my data goes. So what is the cloud? And they have no clue. So you tell them it's a computer that somebody else is running for you.
Yeah.
And then suddenly they're just like, that confuses most people. So it's very hard for us to actually have these conversations and sort of put it out there in the public when, as an industry over the last 10, 15 years, we've been keeping a very low profile deliberately to avoid being caught up in a lot of legislation and being caught up in a lot of public hype.
Yeah.
So as an industry, we've kept that sort of low-key profile. And I think if we want to shift that footing on that, then we've got to try and get some. I mean, Australia is a great example. We don't really have a peak industry body for data centers in Australia. You see a few organisations around. I mean, we've got iMasons coming in later on today who are doing a really good job trying to get some interest and some raising the profile on certain things. So particularly around sort of sustainability, STEM, and other key pillars for them. But there's no real peak body that advocates for us with government, and that's something we're probably missing in Australia.
And Peter, I should imagine part of this also is a security issue about having, I mean, you don't want prominence to a data center because it could invite attacks on it if people were aware of it. And you as a supplier, you're very conscious about the security requirements when you're choosing where people can, where you can host your loads.
Absolutely. I mean, I was going to say that the commentary by the guys is spot on. The IT industry have done this great job of commoditizing itself and removing complexity without removing complexity, just telling everyone that. So they end up with an iPhone or a laptop and magic happens. You know, it is the closest thing we've got to magic, that people go, it just works, and, you know, not realizing everything that drives it and the power. I mean, on security, we are super focused on that. And whenever we've built data centers, they just look like regular buildings as much as we can make them look like regular buildings. On bases, they just look like every other building on the base. We're not very good at design. They're just a box like every other building on a military base. But we also talk to our providers about that as well. And, you know, we are very low key about where we host data and how that works, and what it does. I mean, what we have done as a government, the Australian government have set out a number of hosting arrangements with providers that we've gone really hard into data center providers where we've made them qualify for different classifications of hosting. We've actually gone through and said, we need to see not only your building, not only your land, the equipment you're running, the fire controls, everything you've got. We need to know who supplies it, how it works, because there are countries and companies that we just don't trust, that don't get a tick. So we will say, to meet our highest standard of hosting, you've got to go through all these processes. We are laser focused on that, because what we know with data centers and compute in general is you're only as good as your weakest link. You know, we literally have seen data center providers that, as it turns out, look very sovereign, but have a shell company owning them in Hong Kong with some other ownership somewhere else, and suddenly that just becomes a risk for us. So, we are really focused on that.
We're going to move on to the next top question I wanted to explore with you, which is how do we balance sovereignty, security and collaboration in a globally interconnected infrastructure ecosystem? And Peter, you said something really quite interesting to me, and we were talking about the idea of data sovereignty, and we were then got talking about Ukraine and how Ukraine really hardened its defenses by using public hyperscalers. And I thought that was a very interesting perspective.
Like as a nation and as the Department of Defence, we are really focused on sovereignty and building in secure controls to protect the data and the assets that we have and host them in Australia, on Australian infrastructure, whether that is provided by hyperscalers or domestic capability. We build a set of controls about geo-locking content. But of course, like everything, and I think this is kind of the reality of the world we live in, is people need to be prepared to say, and I think people attribute this to Mike Tyson. I don't know that he actually said it, but a plan is only as good until you get punched in the face. And I think Ukraine was a really good example that Ukraine has been amazing, and one of the things that has been their most surprising to a number of people capabilities is their cyber resistance to Russia. They have held out really well. What they did do though was they had all their domestic data centres blown out of the water in the first very short time. They moved all their secret and classified data assets to hyperscale cloud, public cloud, and ran it in public cloud, and they still do. And as far as everyone knows, and as far as we know, they haven't been compromised in public cloud. The hyperscale security protections have protected them from Russian attack. It's pretty impressive. But they made that move where they had the same sort of sovereignty restrictions that everyone else does around the world going, because they're not in the EU. So they couldn't say we're in EU so we can move to other EU nations. It just was a punch in the nose and made them really pivot. And I think we all kind of, we sit in our preparation and planning going, what does that look like for us if we have similar issues domestically here? I mean, we're a long way away from our adversaries, so the likelihood of some of those attacks happening in the way they did, with data centres being destroyed, is less, but cyber attack is high.
But you said to me about, we get precious about sovereignty and keeping it on premise, but all our military equipment comes from overseas. Of course it does. So are we being honest with ourselves if we say, sovereignty is an issue just for data but not other things? Australia will never fight a war on its own. We will fight with our partners, and we need to think about sovereignty and security in the same way. Adam, one thing you said to me, one of the great things about technology is it's cumulative. And I wondered, how that benefits, what that is in your mind and how that benefits you.
I think a lot of the technology and advances, particularly with AI, we will find, and you're seeing it with these releases, if we had ChatGPT and then maybe 6 months till the next big iteration of ChatGPT or Claude or whatever the equivalent is, and now every second week we're seeing a new iteration of the latest model has been released, or people are learning off each other. So the AI companies in this context. And so what we'll find is as the compute and capability increases, it acts like a flywheel moving faster and faster. I think it's Kurzweil that has a saying about this. I'm going to butcher it, so we'll have to Google it later. But fundamentally, it is around that technology that is reinforcing the next iteration. So you're moving faster and faster and faster. And we're seeing that already with the AI spectrum. So I think many of the issues that we're seeing, I'm a big advocate that some of those will be solved. Like if we think about things like penicillin was made by accident, and if you look at the compute capability, think about battery storage, for example. We know we obviously build brilliant answers with battery storage by working out test this, test that. If you can suddenly go test everything with everything, and then you might go, oh, this actually does improve it by 27%, or that's a very big improvement, but yeah, improve it by some things. So I think you'll find significant advances. We're already seeing that with stem cells and the like, so I'm sure we'll see that elsewhere.
And what I'm hearing that say is you've got to have the confidence that sometimes these intractable problems, the solutions will come as you go down the path to them, because minds will be applied to it.
I think so, but always say please to your ChatGPT, so when the robots come.
Yes.
But no, jokes aside, I think we'll absolutely see some improvements in the compute power that we're unlocking through these investments.
Matt, you were talking to me about how you look at the things in terms of your supply chain and what people are doing at the front end of the supply chain and how you can leverage off the back of that. Could you sort of share that thinking with us?
Yeah, so I think from memory, the conversation we had around that was looking at Vertiv in particular, who are doing a lot of work and a lot of partnerships with NVIDIA. So if we're looking at it from our side, it's always been a case of the data center clients would be the leads, and we would have our partners supporting us and coming in to provide equipment, and we would sort of just basically take the equipment from them, implement it, use it how we wanted to use it. And I think over the last few years, we've seen a shift, though, where a lot of the big global players are actually starting to talk to each other earlier. So they're doing a lot of that integration work. So if you look at NVIDIA at the moment, they're not just selling racks or they're not just selling processors, they're selling complete cluster solutions. So we're getting full-scale pods coming out of them now, which are fully integrated with cooling. They're fully integrated with supercapacitors. So they're starting to take care of some of the problems that these racks have themselves. And the reason they're doing that is that they're starting to talk in a much earlier stage with the big suppliers. So they're getting that technical knowledge coming in from partners. So for us as co-location providers now, it's rather than just purely sort of going to a design team and saying, give us a product, this is roughly what we want. It's up to us now to actually start talking to those same suppliers earlier and start to bring some of the smarts that they're talking about with the equipment users and start to bring that in much earlier in our design processes. So for us, it would be going to one of the big equipment manufacturers who are working with NVIDIA or working with another chip manufacturer and saying, what's the next thing coming down? What do you expect to see? What do you think you're going to need? And then we can start to build that into the data centers to give ourselves some flexibility and future-proof ourselves to a degree.
But you also said to me that there's the other end of the supply chain, the demand from the customers at the end, and how important it is for people to get into the process as they're planning where they want to put the loads to help you in your planning for the data centers. And I'd be interested in that.
So it's very much a case of, as we were talking earlier, we're looking at designs and trying to figure out what it is that we're going to be building next. In the same way that we would look at supply chain and say what's coming down the line, is for our customers, it helps them if they can actually come to us and go, well, we think over the next sort of 5 years, again, we don't know what it's going to be more than a year out, but we think this is where it's going to go. We kind of want to see these things coming in the buildings. So for NTT, we're a speculative builder. We'll go ahead and we'll start to construct a facility before we get an anchor tenant. We're not waiting for that to come. We're a build it, we will build it, and they will come in a similar way the NEXTDC do. And by doing that, we're effectively locking ourselves into something. But if we get a client and a client partner comes to us early enough and says to us, this is the kind of thing we're after, can you make sure that you're able to supply that for us? It makes it much easier because we build that into the product right from the start. So for us, we're selling a product. We're selling a data center, and that's our product.
Yeah.
What that product looks like is shaped by the market and by the demands coming in from our clients. So the sooner our clients can start to talk to us and tell us what it is that they need. If, for instance, if the Department of Defense comes in and says, we know we're going to be putting pods in the next 5 years, can you make sure you're able to deal with a 2 megawatt pod? Then we can look at that in the design phase. We can build that in. We can still have the flexibility to be able to deal with a much more standard cloud solution if we need to, but we can also make sure we can deal with and capable of dealing with a high density pod configuration. And we get a much clearer sort of visibility and view of what that's going to be. So start talking to us early, start talking to us as quickly as you've got a view of what you're actually looking for. And then we can sort of pivot our solutions to make sure that we're able to meet what you need.
But one of the things, Peter, that's going to most influence the data centers is how much AI capacity you're going to want, how many GPU processors you're going to need to actually drive it. And yet, you can't really have any feel of what that could be. It could be small, it could be enormous in somewhere like defense.
I mean, I think I would say it's enormous. Like it's like as we were saying before, all I can tell you about demand is it's just more. And I think this is the challenge with AI. As it becomes more mainstream, and it evolves and grows.
Yeah.
And that is a real challenge for us. And to the point just made, I think we are challenged because as a nation, where's all our infrastructure? It's southeast, a little bit west, but we need infrastructure in the north, and it is uneconomic to build data centres in the places we want them. So we are saying, what do pods look like? What can we stick in a shipping container? But we also, I guess, building on the other point is, there are things that are intractable problems today that we know, we just have confidence will get solved. The compute for AI will become more miniature. The power density that we can pump into smaller form compute will increase. What we can do on a small factor blade set of service today with 2 laptops, took us half a data center pod, a Schneider pod or something 10 years ago. Like, we are just seeing amazing capacity increases, the amount of power we can drive through small factor. So we are optimistic that we're going to be able to do more with less, or the problem is with power, probably more with more. But it is really hard to forecast, except we know it's going to be more.
And you said to me, Adam, you're getting good at making educated guesses on the things. So
For sure, and I think Matt will be the same. We certainly, we're NVIDIA DGX partner, so we are working with NVIDIA and talking to them very early in the piece to go, what's your next iteration? And the iteration after that to, as you say, try and understand what that would look like, to make sure that we have the capability in what we build to support that, so we can support it today, but also the next iteration, the next iteration. So I think, as you touched on with some of your manufacturer OEMs, really important to have those discussions early.
Okay, now I've got a final question, because there's a lot of people in this audience probably work in infrastructure in corporate Australia and probably looking after data centres, and you're painting a world where that's probably going to get less and less as a requirement. So I'm really sort of wanting to say, what do you see the role for infrastructure people will be in a future where organisations don't have their own data centre? And I'm going to start with you, Adam, because you've got an analogy about a trumpet. And I'd like to tell us what your trumpet analogy is.
My trumpet analogy was, I've been in data centres for maybe 18, 19 years, and over that time you get really, really, really good at playing the trumpet, in this case. And I call it tooting the trumpet. I'm sure it's not called tooting the trumpet, but let's go with tooting the trumpet. But with AI, essentially, what it has done for me personally is it's made my tooting a little bit less effective. So let's say I'm 95% a good tooter, but I can now be 70% effective at many other things. And so I think if you're running infrastructure for a data center, that's not really, as to Peter's point, the core value of you in a company. If you're an IT guy, running the data center is not a core value. And to be frank, you're not going to be able to do it in some period of time. If you're talking about a 20 kilowatt, 30 kilowatt, 100 kilowatt rack, it's not going to be on premise. And so I think the challenge now is, how do you transform into all the other cool things you could be doing for the company that IT will enable? So I really think that's you should be playing with AI all day long to be seeing what's coming, because it's coming very quickly.
And another point you made to me as well, if we're having difficulty putting stuff in fully built data centres, you're not going to get it into a corporate building in the middle of Sydney in a data centre with the power demands that you need for that. Matt, what do you see as the role for infrastructure people in a world where data centres don't exist in the corporate space?
So I don't actually see a world where they're not going to exist in the corporate space. I think it will evolve. It'll be different. It won't be necessarily what we look like now. But I mean, if I look at it purely from an infrastructure perspective, at the moment we're going through this massive growth. We're building out huge numbers of data centres, and that can't go on forever. We know it can't go on forever. But once you get 10 years down the line, 15 years down the line, 20 years down the line, there's going to be a whole fleet of facilities out there that are going to be coming to end of life. They're going to need retrofit, refit, they're going to need retooling, they're going to need changing, they're going to need more power adding to them, more cooling, different systems, different configurations. So it's going to be there. This is infrastructure. This is deep infrastructure we've built, and it's going to need maintaining, it's going to need refreshing and updating. So I don't see a world where we're not going to need those people and we're not going to need those skills. It's just going to look a little bit different to what it does today.
Okay, well, Peter, when I asked you this question, you spoke of an analogy with virtualization. I wondered if you could share that.
I mean, I remember when I was the CIO of the Department of Treasury, we had a couple of data centres, and virtualisation came in a big way, and we jumped on it, and the amazing enhancement in compute for us. I think Australia was the world's leader in adoption of virtualisation. As a nation, we were far streets ahead of other countries. But I had a bunch of guys in my team who were like, I don't want to learn this virtualisation stuff. I used to run servers. I got it. I'm not interested in doing something different. It's just always been thus, whether it's virtualisation or whatever. I'll give you another analogy, which is in the history of warfighting. Someone at Defence told me this one was, a long time ago, they used to make swords out of copper, and people had copper swords, and they were better than wooden sticks, and you could sharpen them, do a bunch of things. The first time they fought the guys who invented steel just break copper and cut straight through it, and those guys really copped a hiding. But I bet you, but the next thing was, the next time they had a fight, both sides had steel, and you evolve, and that has always been the way with technology. And I think we have to just adapt and grow, and as AI demands power. Organisations like mine say, we don't want to build data centres anymore. We want to have these guys build data centres. We want to use hyperscalers who are building data centres probably through these guys and using them. We want to go up the stack because we want that thing that we're calling commodity, which is completely complex and a big challenge. We just want to get out of that. That is where we evolve. And it just means we're going to have less people doing those tasks. And as automation comes along, we'll have less people doing other tasks. But we've got to find meaningful jobs where they add value and are smarter, whether that's for application layers for us, or building warfighting capability. The infrastructure is less important for us, but we still need to manage it, and we still need to have observability, and we need to know what's happening, and we still need to manage supply chain through our partners. That is always going to be the case.
And infrastructure, what constitutes infrastructure is changing. It may be less a server, it may be an agentic AI involved or something like that. So you have to think about where you can apply your skill sets.
I think corporations and organisations just have always had the desire to move up the stack. That's kind of the nature of the world, that, if someone else can take care of something down the stack for you, you want to move up it. That's where logically, you add value. It's your cool application and the end user and what they do with it and how they perform their task that makes a difference. For us, it's fighting a war, having intelligence, defending the nation, whatever it might be, is our business. Flying planes, ships, logistics. It is not running infrastructure. If someone else can do that, that's the mission.